Okay, so number 6, find the curl of f and the divergence of f. So this should be a pretty simple and straightforward question. You have to know how to find these two things. And maybe the notation like these will give you a little clue, because this dot product or the cross product notation tells you that in order to find the curl, you have to take the cross product of the gradient operator, which we call, right, partial x, partial y, partial z, and then f is p, q, well, that's not a q, p, q, r, right? And so this is the p part, this is the q, and this is the r. So, and then you do, your operation as in cross product, it's ry minus qz, and then negative of rx pz, and then the last one is qx minus py, and so on, right? That's the curl. The divergence is even simpler. It's p with respect to x, and then the partial of q with respect to y, with the partial of r with respect to z. And the notation is this, because this reminds you of the dot product of this gradient operator with f, right? And that's exactly what you see here, right? So these two really should not be causing any trouble here. And you can see number 6, the curl is, and again, let's go ahead and just make sure you understand this. The first component here would be the partial of this with respect to y, that's e to the y, minus the partial of this with respect to x, with respect to z. So now x is treated like a constant. So x comes in the front. So it's, ey minus, and then x times e to the xz. All right, comma. The next one will be the negative of this minus this. Okay, so negative of, and when you take the partial of this with respect to x, you don't have anything, that's 0. And then you take the partial of x plus z with respect to z, that is simply 1, right? So it's negative of -1, that's positive 1 for the y coordinate. And the last coordinate is, of course, the partial of this with respect this minus this. So with respect to z is, the partial of e to the xz with respect to x, which is z times e to the xz, and then minus the partial of x plus z with respect to y, but that's 0. So this is what's left. All right, the divergence, you take the first component and take the partial of that with respect to x, that's 1. And then the partial of e to the xz with respect to y, but there is no y in here, so the middle term will be 0. The last term, the partial of e to the y plus z with respect to z is clearly 1. 1 plus 1, the divergence happens to be just 2.